Hey everyone, in this video we're going to be taking two projects, one document summarizer with Streamlit and another with FastAPI chat app, which can take in multiple instructions to combine it with the system message, also come with light and dark mode. And let's begin with the document summarizer. I'm going to copy the text from my 1000x Dev masterclass and I'm going to paste it here. I can also actually upload text or PDF files. Here I can select the summarization methods, like explain like on 5 bullet points and concise. And let's select all of it and click on summarize. And we will get each summary in its own uh, column. And once all the summaries are done, and we are able to download all the summaries as well as a text file, as you can see. Like I said, you can also upload files as well. The second one is interesting. You can actually enter short instructions. For example, we can say, talk like a pirate, always use emojis, you're always polite. And when we try to talk to it, it's actually talking like a pirate, a very polite pirate who also uses emojis. We can actually get rid of these instructions and actually add as many as you like. After you edit your instructions, you click on Update Instructions, and then the behavior of the chat will change. Code files for this will be available at my 1000x masterclass. Because we actually coded all these, we actually coded 3 projects, including the 2 which you've seen, and plus the chat with memory, if you have seen that video, which is like a regular chat which creates memories so that you can actually continue the conversation without keeping the entire message history context. So we will be reviewing the code for the 2 projects which we looked at, but after that, there will actually be a preview of the live stream that I did, and I've recorded that live stream and full video, full 2 hours of it, live coding these 3 apps is available at my 1000x masterclass. 1000x masterclass actually comes with 14 different live building of different projects. These 2 are the cursor live coding from today, and each one of these projects include a video in which I built these projects from scratch, plus the project files themselves. Link to this will be in the description. So let's begin by reviewing the code for document summarizer. But like I said, if you wanted to watch how I built this, you can, if you become a patron, you'll have access to the video under 1000x masterclass. So this one is called docsummarizer.py, and we are doing all of our imports. You can load your API key directly from an environment variable or from a .env file if you use the load.env, or you can insert it here. Here we are defining a dictionary with summary methods, concise being a brief to the point summary, detailed, bullet point, explain like on files, and academic. Here we have a summarize text function. You're a helpful assistant that summarizes text using the method which we are going to pass. Summary method, provide a summary in JSON format, key summary, key points, and additional info. And then we call GPT-4o with the system message, and we pass the text, and it returns a JSON mode response, JSON response. Extract text from PDF function is to actually read the PDF files for page by page. Get binary file downloader is to actually allow user to download the generated summaries, as we have seen. This appears at the bottom. The main the main function is going to print the title of the project and display a file uploader, and then it displays a text area which says paste your text here. Here's the method selection, and it uses the multi-select Streamlit element. And if there's uploaded file, we check if it's a PDF or plain text and actually use the proper functions. Otherwise, it's just text input that is pasted. And if the button summarize is clicked, then we create columns for as many of the selected methods. And with a spinner, we enumerate over selected methods. We summarize each one of them using the method and using the same text, and we create a column for each one. And we add all summaries to the list. And then we create a button for all the summaries by joining that list into a string and creating a base 64 encoding of it and then creating this link. So this is pretty simple. But like I said, if you want to watch this being built in real time, you can find that video at my 1000x masterclass. Now let's take a look at the FastAPI chat app. It's a full stack app. So this is like a regular app, but the interesting part is that we are able to insert multiple instructions, as many as you need or want. This gives you more fine-grained control over the behavior of the model. So I'd like to take a moment to talk about the benefits of becoming a patron. As some of you may know, in the last year and a half, I've spent 3,000 hours, over 300 projects as a patron. You will have access to all the code files so you can get inspiration and iterate quickly. Another benefit is that you'll have access to all my courses. And my most recent and most proud one, the 1000x Masterclass, teaching what I've learned on how to code fast and efficiently. Also the Streamlit course and the Fast API course. In my Patreon, I also have tiers in which you can connect with me one-on-one. Check those out as well. So if we look at it like this, the doc summarizer is in the working folder. FastAPI Chat app is a static folder which has the index.html, and main.py is our FastAPI app. Maybe let's begin with the main.py. We are again using the load.env, but my OpenAI API key is automatically detected from my system environment variables, but you can insert it here as well. We define our FastAPI app and OpenAI API key either from the environment variables or insert it here. We point to the static folder, which is going to contain our index.html, which also includes the JavaScript as well. And then we define our first route, which is the home page, which is going to serve the index.html with HTML response. Our second one is going to be a WebSocket endpoint called /chat. This is going to receive continuous messages, and it's going to get a message type and content. If message type is a system, then system message is going to equal to that content, and then we insert it into the messages list. And now we make a so then chat completion with streaming is going to call GPT-4o, and here we are streaming the response, and we are sending it back each of the chunks with a WebSocket, and then send a new line character indicate the end of the response at the end by /n. Handle errors, and this is how you can run the code, quickly running it, or you can type uvicorn main :app, main being the file name and app being the FastAPI app, which we defined here. And you can also use dash reload if you wanted to auto reload when you make changes to the main.py file. In the index.html, we are using Daisy UI. Daisy UI is a popular components library for Tailwind CSS. When you use it, you get beautiful components that looks really sleek. And you can also modify them using Tailwind. That's why we are using the CDN both for Daisy UI and for Tailwind. And here we are just defining the containers, which these are the instruction container side panel, and then the main chat area, essentially. And then we have the chat container where the messages are going to go in. And we get them from the DOM. And here we are establishing a WebSocket connection to the chat endpoint, as we have seen right here. This is the route that we are connecting. And then when we receive the messages, pretty much we stream them to the UI. Here is the function to add new instructions and remove instructions and update system instructions by reading the text values. And this is how we detect the key press and the theme controller, which is going to change the theme to light or dark. And that's about it. So it's not very complicated, but building it in live was actually very helpful. So right now, and we also built this chat with memory. And actually, I have made this video about this. It's called this one, the memory layer is a memory system for LLM chat application. Actually, watch this video. I do a code review there for it. But the difference is that I will be playing the first 10, 15 minutes of the live coding session we did with my patrons, and you'll be able to see that being built. in real time. And if you enjoy the content, you can find the rest of it, the full video, in my 1000x masterclass, like I said, along with 14 other projects there. And if you're enjoying my projects, do check out my website, kohive.live, where you can find all my videos with a convenient search. And my patrons can actually download the code files as well. Just click on any one of them. And you will also have access to all my courses, including 1000x Masterclass and the Streamlit and FastAPI course. I also have weekly AMA and live coding sessions with my Architect Plus patrons, so check those out as well. The rest of the video will be the preview of the live coding session where we're building all these three apps. But the first one is going to be the chat with memory. Like I said, you can find the code files for this at my Patreon. Thank you for watching. Okay, welcome everybody. So we're going to be using Cursor to build some applications. I'll try to show you how I use it in the hopes that it will benefit you as well. And a little bit ago, I was saying this is the Cursor's website, cursor.com. You can download it. You get 2 weeks free pro version when you download it. But in my opinion, you'll love it and you will want to get this as well. I mean, I actually just subscribe for a year. I use it a lot anyway. But once you download it, this is what it looks like. It's an exact replica of VS Code, except the side buttons, right, that you see on the VS Code is up here. Yeah, extensions and everything. So let's go ahead and create a chat.py file. So I was thinking we'll try to build the memory layer, the video that I just my most recent video. We'll try to replicate it. I didn't prepare extensively for it so that it will be good if we run into issues so we can all try to solve them together. Also, if you have any questions, please use the hand raise feature, right? Please feel free to interrupt or speak anytime by using the hand raise. So we're going to build this memory app, right? And I used to always use the chat feature, which you can turn on with this toggle AI pane before, because that was the only real thing that was available, really, initially. But more and more, when Control or Command K came available, I started using that more and more because this one outputs just code more so than additional like explanations or something. But if you needed a quick answer here, for example, I can say hi. If I generate, it'll probably generate a print statement because it only generates code. But if I needed maybe an answer based on some code piece, for example, if I did have a print statement, I can actually select it. Whatever you select will become its context, right? And change this to hello patrons. Yeah, see, it'll delete this, it'll update it. But if I only wanted to get an answer, like what is this, then I can do Alt Enter, or you can click this quick question and it'll answer it, kind of like you would get from the chat. Anyway, this is really useful because once you give it a like let's say change this to hello world. So once it does that, I can the really cool feature is the follow-up instructions, but in a function. Yeah, see, it create a function. So you can continually enter follow-up instructions, and it'll know what it has written previously. It'll know your previous instructions. So it's a very iterative approach, much like you would do in ChatGPT or Claude Chat, right? But you'd have to continually instruct it, and you'll have to always copy paste in between. But this way, you can actually build quite complex apps, especially since Cloud 3.5 Opus now outputs 8,000 tokens. You can build almost up to close to 800 lines of code in a continually like instructing this, and it'll do that. Anyway, so having said all that, let me make sure the recording is working. I think so. Good. So, so I'm going to Control K and ask it to create a terminal chat app with GPT-4. I can say GPT-4o, but it won't follow that instruction. So this should actually create a working chat, just as simple as this, right? I did say terminal because if I didn't say terminal, then I'm actually going to zoom out a little bit so more of the code is visible, but let me know if it's too small. if I didn't, if I didn't say, oh, if I didn't say terminal, it may have tried to create a Flask app or with some kind of UI or something. But anyway, so I can accept this or I can review it. Once this code is written, even though it hasn't been accepted, it's actually functional. I can run it. So because if I were to accept this, then the follow-up instructions will go away. That doesn't matter. I can accept it and then select all of it and then do another Control K. Well, follow-up instructions have gone away, but I can add new instructions. But the thing is that my previous instructions have disappeared. You can bring them back by pressing up arrow. You can cycle through your instructions say, that you have put by using up and down if you needed it. Okay, so let's see. So it wants to use .env. You can use that, but we're not going to because we're going to get it directly from the environment variables, or you can input your key here, your API key here. Let's take a look. So when you do this, it's going to make mistakes because it's going to try to, because in its training data, it probably has a lot of examples from the previous OpenAI library. Say this chat completions is wrong, actually. It has to be chat.completion, so I can fix that. And this dictionary style response is not correct. It's now pedantic object, so it's the exact same thing, but you refer to them as like attributes with dot. Once we do that, it should be all good, but except we do also want to put in an O here. So quite literally, you can start a quick LLM app like this, and obviously this is the backbone of most LLM applications. So now we have a chat app which we can chat with. Oh, okay. So this is because I updated the Python in my Honda environment. I need to deactivate this and Honda activate basic 2. That's just environment stuff. Let me do that here too. Okay. So now let's run it. Yeah. Say hi, and then it'll print hello. So we are working with it right now, but except it's not streaming responses. I can select it and use stream true. It should make it streaming because it knows how to do that. Yeah, see, it created streaming mode now, so we should actually. Oh, okay. I I sent the wrong message, but nevertheless, you see now we have streaming working. To make it better, we can. I'm always selecting all and then adding an instruction: use term color or colorful printing. And I make a lot of typos, which doesn't end up mattering much. So now it's going to update it. You can see all the places it has updated. You can also accept these selectively, but almost always, it's cloud is pretty good. You'll probably accept all of it most of the time. See, now we are printing colorfully, so that's good. So at the end of the day, we built a simple chat app, just like that. And now I'm going to create a new file called memory. Let's say memory.py, and I'm going to do a control K here, and then I will refer to the previous file we created by typing the add symbol and going to files and selecting chat.py. So now it has added this. I could have just simply copied this, right? And control K pasted it here. That works, but add command allows you to reference different files even by typing quicker, more conveniently. So now we need to create some memory system. How this is going to work is perhaps when the chat is ongoing, we have a conversation history. We have this conversation history. We make another call to let's say GPT-4 mini, and we wanted to use, let's say, JSON mode and return some memories, right? Like key value pairs. It's the simplest way I can think of doing it. So let's say in this file, we want to create a simple and modular memory system, which will use GPT-4o mini and JSON mode to use the conversation history to extract important details is important details as memories, let's say in parentheses, key value pairs. It's going to write the instruction itself too. So key value pairs, we want this to be reusable across many LLM apps. So this should only return the memories. Yeah, so the more detailed instruction you write, the better it will be. Let's see what this does. Okay, let's accept it and take a look. When you accept it, it's easier to read. So extract memories, it's going to take in a conversation history. We can get rid of this type safety, so it is easier to read. So quite literally, it's going to take in a conversation history, prepare the conversation history for API call, it says. Didn't have to do that, but it did it. It is system message. Extract important details from the conversation as key value pairs. Okay, this can work, but now it's using the conversation history as the message history for this, uh, for say formatted history. This is not what I was hoping. So let's go back. Actually, I'm going to do Control Z all the way back and let it generate it again. Okay, it wants to create it, do it like that, so I can cancel this. I'm going to then say, will insert the conversation history with an F string, so we can add it as a variable. Yeah, see, this is just much easier to read. You see what's happening easily. So we're just going to have a prompt giving the following conversations to extract important details as key value pairs, focus on factual information, preferences, significant statements. You can change this. Just Claude wrote this. Extract memories as JSON as the following example. Like say it'll also fill it in, dot, 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 and say return as many as needed, let's say. So this is the system message for memory generation. We insert the conversation history, and we're going to make a call using JSON mode, and it's going to return that memories. We just return the memories. Merge new memories with existing ones, updating if keys already exist. This is interesting, actually. So we didn't ask for it, but it did that. Get relevant memories and to use more specific retrieval methods. Yeah, we don't need these. Let's delete that because that's going to get complicated. Because I have done stuff like this before. Like if you want to update this particular key, like that is definitely possible, but it's a bit more complex. I just would like it to return full key value pairs each time, full memories. That is how I made the video. But essentially now this is going to take in conversation history, return memories. Okay. And this is a single function. So now we can actually use this here, like from memory, import, extract memories. And let's say after the assistant has replied, we can use it here, extract memories. And now extract memories, then we can assign it to memories. Uh, and then we can print it. We can also now we have these memories, we can use it any way we want, right? We can input it into the system message. That's how I was doing originally. But we can also add it as a conversation history.append as a user message. just like that, memories. So now it should give us some memory, even it's going to work sequentially. We'll fix all that, but let's say let's add a new function which trims the history, like I've done in the video. Add a trim history function which trims the conversation history to the latest and many user assistant message pairs, right? So